All right. I think we're live. I hope we're live. Uh, wow. So, okay, we're streaming. This is on Twitch. Hi, everybody who's here. I don't know who all made it, but thanks for showing up. Uh, this is my first time doing this. The idea is, I guess we're just going to spend, what, in about an hour, I think, at least an hour. By the way, can we go longer, Paul, if you're still there? Oh, okay, good. Um, is there a way for me to see what people are saying? Is there a chat I can look at or something like that? Or is it just me talking into the microphone for an hour? Okay, so I'm doing this. Wait, not Twitter.tv, Twitch.tv. Okay. Right. I'm having a one-sided conversation with a voice in my head. Sorry, everybody on the stream. Yeah. Now I can hear myself. Yeah. Okay. All right. Good stuff. Who all is here, if anybody? All right. All right. Okay, good stuff. Either way, I think we'll just get started. Am I looking at the right thing here? Stream chat? There you go. That looks right. So, okay. Hi. There you go. Hi, Jay Walter. Thanks for joining us. So today I just planned on working on my book. I've got a book called Reactive Spring on which I'm working. I was kind of hoping to get some feedback, to do user experience testing. You know, like Microsoft is famous for putting people in front of their APIs with nothing but an IDE and a compiler and saying, okay, figure it out. You know, try and make it work. And I don't have the budget or the ability to do that, so I figured I'd just talk to people about what I'm doing and see if that actually resonates with people and if it makes sense. And if it doesn't, well, since I haven't written the chapter yet, we have ample time to fix it. Hi, NS Ardina. Thank you again for joining us. And so, uh, you know, validation would be useful. Where there's confusion, that would be super useful, obviously. You're helping me out. I'm going to be writing a book based on the feedback on this, or chapter rather. I've already written a lot of the code for a lot of the things I hope to cover in the chapter, but not all of it, right? And so perhaps there's room to expand the scope of what I'm doing. That's another very distinct possibility. And so with that, I guess the idea is I'm if you've had the dubious pleasure of seeing me talk in the last couple of years, you'll know I'm all about that reactive life. I love reactive programming and the opportunities that it portends for our distributed systems, for our Kubernetes-based applications in the cloud, right? Better scalability, more efficient resource utilization, etc. Uh, and so this book is all about reactive programming with Spring. And it's taken me what's the right word? What's charitable? A long, 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 long time. That's my last name, by the way, so it's doubly apropos. It's taken me a long time to get this done, in no small part because things are changing, right? Last year, I was also on planes a fair bit, and the year before that. But this year, I've just been writing as much as I can. And, you know, if there is a silver lining to the pandemic, it's that it allows me to weight the priorities a little differently, right? Getting on planes, less important. Things I can do in one place, sedentary things like writing a book, more important, right? So there's that. So this chapter, this whole thing is one. It's one of the last two chapters I've got to write, right? The other one's the one on Kotlin, and I think I can, you know, if everything goes right, I'll get this all done. This chapter will be done in the next week. But the chapter is the culmination of a lot of the stuff that's already in the book. So if you haven't bought the book, that's fine. What you need to know is that there's a sort of arc. We go from the basics of Reactor, and well, we go from like the basics of Spring Boot and then to Reactor, and then we look at data and then web access, and you know, we look at things like RSocket, right? I just finished that chapter a few weeks ago, big old honkin' 70-page chapter on RSocket, and so now I've got all the primitives, all the sort of things you're going to need to be able to build reactive services in the rearview mirror. Now I can assume the knowledge of all that stuff. And now I want to talk about service orchestration and composition, right? The application of reactive principles to the task of aggregating data, doing scatter gather kinds of flows, that kind of stuff, right? So lots of use cases here, and a part of that is reliability, right? What naturally falls out of building distributed systems is this need for reliability. So let me go through some of the stuff that we've got here. Again, I've already written some of this because I don't want to like put all of the work on you as my my audience, but I've got some of it. And this code, by the way, oh yeah, actually the code, the book itself, not so much, but the code, friends, the code is actually all open source. And so you can follow along if you like. It's here, reactive-spring book or / rather orchestration, and then there's just all this code, right? I'm taking some notes about what I'm going to be doing in the, there you go. I'm taking some notes about what I'm going to be doing in the resulting chapter. Some examples already in here. And indeed, this README, I should update that right now. The README is already out of date because now I've already got a gateway, right? Gateway example. So 2DD, right? I've got some gateway examples already coded. I just need to document them here. So, so let's go through some of these use cases, okay? I cover normal scatter gather kinds of examples, okay? So scatter gather, when we talk about microservices, one of the natural goals of microservices is to have discrete services handle individual pieces of data. They own their own data, right? And so I want that discrete data to be a bounded context, right? A microservice is, if nothing else, a domain-driven design bounded context that's been exposed over the network. And so the API is just the way that you affect mutations on that state, right? And if you want a view of all that, there's two ways to do it, right? If you're doing something like CQRS, then you expect each microservice to tell, not ask. And what I mean by that is each microservice should publish or broadcast its state. How's that? Is that a little bit better? There you go. Each microservice should publish or broadcast its state to everything else in the system. That's one way to do it. And that's an event-driven messaging-centric approach, and I quite like that style, and that's very useful. The other, of course, is even if you've done that, even if every microservice has broadcast their state to everything else, and everything else has kept their own view of the other services, sometimes when it comes to dealing with the web, you just need an aggregation of some sort, right? Something that pulls together data from different services. And this is where scatter gather kind of orchestration comes into play, right? You get these use cases that are based on my ability to concurrently call data from this service and from that one, pull them together in some way, and then render them or respond to them or work with them. And so I've got this. Here we go. I've got this scatter gather example. It assumes that I'm connected to a service registry. I've got Eureka, right? I've got a Eureka instance configured here so that everybody else can play the home game. You just go to the Eureka-service example here, and does that? There you go. That is so cool. This is one of the nice things about the streaming setup is that I finally figured out a way to get my zoom in, zoom out to work over the internet, right? Like I can do it on stage all day long, but now because of the way I'm doing the streaming, it actually works as well. So anyway, you can go to the Eureka service, do Maven space -f space pom.xml space spring -boot : run. That'll run the Eureka service, and that done, then we can run the scatter gather application. Well, no, you actually need two other things as well. You need two services, and so I've got these are just skeletal nonsense services, right? There's a customer service here. The customer service, what does it do? It literally just pre-computes a bunch of records, objects. There's no database. There's nothing fancy here. But it provides a customer's endpoint, and the endpoint gives you data for different customers by their ID. So you can send in a number. Yeah, the GitHub URL. Did you all get that? I just saw in the chat. Here's the GitHub project, just in case people were. I just saw in the chat there's somebody asking for that, so there you go. Okay. So it's a nonsense endpoint that gives you the 10 records, whatever it is, of people, and it's just you get their information by their ID. So in theory, I can send customers for question mark IDs equals 1, 5, 10, and then I get the details for those 3 records whose IDs I just passed in. So that's one service. What else? I want also an order service. I've created an order service. So the order service is, again, trivial nonsense service, right? Here, pre-computed mapping of customer ID to order, so I can actually look up information by the customer ID. You can liken this a bit to a SQL query that looks up all orders by the foreign key for the customer ID or the customer underscore FK, right? And so this is just a endpoint that, again, given a collection of customer IDs, will find all the records in the map that map to that customer ID. And actually, to compute the orders, I'm literally just generating a random number of order objects, right? This is just so we have something to look at, right? There's no data here in the database. Just a trivial service. The goal here is not to demonstrate how to build services. We will already have looked at that by the point that people get to this section of the book. And then there's what else is there? There's a customer, order, and then profile, right? Profile is yet another service. So same basic approach as the other services. I've just pre-computed some data, stashed it in a map, and I'm making that data individual records, right? So this is a one-to-one kind of thing. I'm not getting multiple records back here. I'm doing it one at a time, right? So this is actually less ideal than what we've looked at thus far. The customer and the order service both allowed me to specify a range of IDs, and I get back a range of entities back. In this case, we have to deal with one record at a time. So for every one record I want to look at, I have to make a network call to get the details here. And that's inefficient. And sometimes that's just the way it is, right? You have to make that costly call, and that gets you into the n+1 problem, right? You're making a call to a downstream service, and you just have to deal with it. Now the question is, what can we do to make that less of a problem? Well, obviously you're going to waste resources. You're going to waste network bandwidth and so on, because you're going to make these constant round trip calls. One way to mitigate that might be to use something like RSocket, right? RSocket at least has the decency to spare you the constant network handshake, right? The connection and ACK and all that stuff. All that goes away once you have RSocket, because you connect at the very beginning of the application, and there on down you can just make network. You can make multiplexed calls to the downstream service. But ignoring that possibility for now, because it's really immaterial to what we're trying to do here, it's still an n+1 problem. I still have to make n calls for every item in that list of items that I want to get. So for every profile, for every customer, I have to make so many different calls, right? Now, that's okay, right? I don't mind wasting that bandwidth. Presumably that's okay for you as well, if you built your service in such a way as to require this kind of access. What I do want to avoid is making the user wait for that, right? Rather than having to query all 10 records in a serial sort of fashion, I'd much rather get all 10 records at the same time, and then that way I'm waiting no longer than the slowest individual request, right? So if I can launch all 10 requests at the same time, or 3 requests or whatever, then sure, I wait as long as the slowest of the 3 to get back, but at least I get the response, right? At least basically it's an O of 1 problem as opposed to O(n), right? So that's important, okay? I want this kind of I want these trivial APIs so that we can have something to chew on, right? We can actually consume them. And the nice thing about these reactive APIs is that you can write fairly imperative looking code. Sure, there's some callbacks, there's some operators, but basically you can look at the code, and wherever possible in that code, the runtime will give you concurrency, right? And I worked at a lot of organizations before I had the privilege of joining the Spring team. I worked at a lot of different organizations where we had what I suppose we would have called SOA back then, right? So we had services that were deployed over the network using HTTP. We even built an HTTP template. So this is before Spring 3.0, right? Before the REST template was introduced in Spring Framework 3. And we had an HTTP template, and we had figured out how to get some HTTP REST-ish, not proper, hypermedia centric HTTP APIs, but what we called REST back in 2009. And these services were all built using Spring and what were they? We weren't using Spring Framework because Spring Framework didn't have REST support at that point. What was it? What were we using? Oh, it's on the tip of my tongue. It's not Xfire. It's the same group though. It's the same. Oh well, yeah, whatever. It's a Apache project, and it worked okay, right? It was fine. And these services were we had multiple services. We had many different services. Any given page in this product that we were shipping resulted in dozens of different network calls that cascaded over to many different APIs, some of which in turn talked to MongoDB, to Hadoop, to a coherence cluster, Tangosol coherence or Oracle coherence. So all of that, that was a long time ago, but we're still doing things that, those same problems bedevil today's organizations as well, because they're just hard to get right. How do I aggregate all this data? And so we built a whole system on top of Spring MVC called pods, right? And the idea was that you could describe zones in a page, which in turn had dependencies, and those dependencies were to be fetched in a certain asynchronous, not reactive, we didn't have reactive back then, but it was asynchronous fashion. And we could say that the rendering of this zone could only be initiated once these dependencies had been met. And we could actually use a fairly declarative data flow description to say, go get these different API dependencies. Go, call these different services and then wait for all of them to return. As soon as all of them have returned, then we can render this one zone. And the benefit of decomposing your Spring MVC view into zones was that, maybe the search results could be rendered right now, but the customer comments or feedback or whatever might take some more time, right? So we had different zones, and we could render the markup. And it was a whole framework on top of Spring MVC. It was like this extra concept designed to support parallelizing the rendering of pages, which is important, right? The time to first byte is so important, and it was a whole thing. It was incredible. I can't claim the credit for that, actually. I wish I could. It was just such a great experience to see people taking this seriously and doing amazing things on top of Spring. But that was 11 years ago, right? That was a long time ago, and now we have Reactive, and I'm just so happy that we just get that for free by embracing Reactive, right? But I think about the pain that we had back then, and just we were so ahead of the time, So now we have this new scatter gather client. This idea is, hey, I've got a bunch of IDs. These are presumably customer IDs, and I'm going to make a call to my CRM client. This is just a little Java class I've built here, and in this, I'm making the network calls to the services. And by the by, notice the syntax here: HTTP :// service ID, and then the path. So the service ID represents the service as it's been registered in the service registry. So I'm using the Spring Cloud Discovery Client to make short work of client-side load balancing. So I can address this to a logical service name, and then that'll result in a individual service instance being resolved via the Eureka service registry. In this example, by the by, I'm using a service registry that's running on my local machine. It works fine, obviously, but I wouldn't, I wouldn't do that for production. Obviously, you're going to need a horizontally scaled, secured service registry. So if you're using PAS, the Tanzu platform, based on Cloud Foundry, we have a Spring Cloud Service tile that deploys a enterprise grade Eureka service registry for you, scaled out, secured, etc. If you're using Azure Spring Cloud, that's also done for you as well. You probably, or hopefully, knock on wood, have some operational insight about how to deploy a service registry as well. And there's many options. I talk about Eureka because it's easy enough to run as an embedded thing on my local demo. But of course, you could use HashiCorp Console or Eureka or Apache Zookeeper or whatever. Lots of good options. So anyway, these URLs represent logical network calls. I'm saying I want to call the profile service, get the profile information for this particular ID, and the actual work is not that bad, right? This is the one where we can only get one record per ID, right? We can only send in one ID, and so we had the n+1 issue, right? So I'm saying HTTP get URI customer ID, retrieve the data, turn it into a profile object. Okay, and then we have the get customers endpoint. Given a collection of IDs or an array of IDs, we can call the endpoint, get all the data, turn it into a reactive stream of customers. Okay, no problem. And then ditto for the orders endpoint. And here I've got a little, I'm not proud, but it's just something to combine the collection of IDs into a comma delimited string. By the by, I love Java. But this is just, there's got to be if you know of an easier way. Was it Axis? Spencer Gibb. Hi Spencer. I don't know if that was Axis. Was it? Maybe it was. It's been. Is that what became of the Xfire stuff? Yeah, I don't know. But anyway, does anybody know of an easier way to just, like in Python, you would just say something like that. Right? That's the equivalent of the barf that is this. Right? It's so much. The Java 8 Streams API is perfect, but this is we've got to do better. This is so sad. How many? And the worst part is I have to create a stream from the IDs, which does nothing except for give me a thing that can handle what I want to do. Then I have to map everything into a string. Then I have to join it into a collector. And I suppose I could make it a little easier by doing static import tricks. That's a little bit better. But is it worth it? Yeah, I don't really think that buys me anything. And yeah, I could also do this. I could also, but that doesn't feel great. Or I could just do this, I suppose, right? I don't know. But now it's telling me I'm. Okay, that's a little bit better, I suppose. Okay, whatever. Not great. I'm not really It just feels like it's worse than it could be. Okay, so I've got my little reactive client, yeah, and now I just want to use that, and so I can do a couple things here. I can. Oh. How are these service names resolved? By which bean? Web client knows about them. String has a on content. Okay, hold on. We've got. Oh, thank you. So okay. First of all, let's try that. So string.join takes a string of strings, right? A sequence of strings. I did look at this, and basically I would end up doing stream. Well, hold on. It'll correct. It'll show me the right way. It'll say what is it? What is this method? This is static stream.stream, right? So stream.stream. Yeah, okay. And then stream of this, IDs, and then map. What is that? What did I just do here? Just do that. I just want to take this bit right here. So then I got to map it, and then I got to collect it into a list or something. I mean, you see the problem? It's not actually much better to do string.join because I still have to convert this array of integers into an array of strings, which is, shouldn't be that painful, but it is. So what was the other option? On array to comma delimited string. So Spring has some good stuff. I could look at that. That's a good point. Array to common delimited string. There we go. Now we're cooking. I should just look there. Presumably that'll call toString on each thing. Let's see. If it's empty string. If it's an array, take the first one. Otherwise, use the string joiner, and it gives you the string value of O, where O, I'm assuming this is just object.toString. Ah, that's so good. Much better. Thank you. So now, let's just remove this nonsense. Now, one of the problems of writing a book is that the way I code is a little different than the way I code normally, because I'm optimizing for the depth of the page, right? How deep is my code snippet going to be? So was it that bad to have a method extracted out for this? Certainly not when it was long enough before, but now that it's just one method call, it's just one dispatch, I'd much rather trade a little bit of the width for the depth, right? I'd much rather get rid of those extra 4 lines, because I'm going to I want to keep these things on the same page wherever possible. And actually, I think I like that result. I think I like the result of being forced to think about what I could fit on one, having individual classes strewn across different pages, not good. Having multiple classes strewn across different pages, that's better. That's okay. It's not so bad to say, here's one class, next page, here's another one, Okay. Thanks, Spencer. This is great. So, okay. Now I've got my little client, and the question was, yeah, exactly. How's this doing load balancing? Well, I have a couple of options. One is you could do, actually Spencer's here, maybe he can help me. Web client.builder. I could do this and load balanced and return web client.builder, I guess. So that's one option. And then this thing here becomes load balanced, and I don't really need this bit here, right? I can just comment that out and comment that out. But the thing is, to my mind, that feels like I'm squatting on the web client for everybody. Like the builder itself is being configured to be load balanced. That means that everybody that needs a web client will need to use the web client builder, which will be pre-configured to be load balanced, I guess. So I don't know if I want to give up that. I may want some. I think in this case I didn't want some web clients to be load balanced. So instead I'm just doing it manually. I'm just configuring the load balancer exchange filter function on a particular web client instance. That way the other ones that are built with the web client builder are not load balanced by default. And this is just a reactive web client filter that it chooses stuff, right? Okay, so there's that. Now, what am I doing? Okay, so I'm making a call. The goal here is for the customer IDs 1275, to get all the customer data, to get all the order data, and to get the customer orders, and just to demonstrate that we can, right? So let's see. What are we doing? Okay, so we've got the customer data. We say client.get customers by the IDs. Great, that works fine. Then we've got the client.get orders. And again, I've got this little wrapper method here. All this does is it logs out when we get new distinct pieces of data, right? So I use the cache operator to tell this particular publisher, this Flux, to memoize itself, to not forget that it's already seen that data before, so that I don't need to I want the stream to be cached, basically. So rather than going to the source, making the network call and so on again, I'm just going to keep it. So I'm using that, and I'm also proving that it's working by doing do on next. This will emit new items the first time around, but the second time around, it's already been cached, so it won't emit anything. So you'll see this run, you'll see receiving ... but one time per element, right? As opposed to each time I subscribe to the stream. Very convenient. So I'm making a call to the customer's endpoint, to the orders endpoint, and then I'm making an aggregate. I'm saying, okay, for each customer in the customer's Flux, get the orders right? So filter the orders flux and find the orders whose customer ID matches the ID of the customer for the order that I'm looking at, and then get the profile, right? The customer profile, the details there, and then I want to get all that at the same time. Basically, I want to scatter gather and get all that stuff at the same time. And so I'm just using, I've got 3 different publishers here. It doesn't matter if they're Flex or Mono, it's just org Reactive Streams publisher at the end of the day. And I'm saying, okay, I want to get all 3 of those at the same time. And I know that these are the, I've got the orders for a particular customer. I've got a single profile, which I had to make a network call for a particular customer. And I've got I've got the customer, right? I've got the customer itself, which is driving this scatter gather operation. So it's the root of the aggregate, if you will. So I'm saying, okay, given all 3 of these asynchronous network bound things, create a zip, do zip. Zip gives me a tuple, and the tuple is only emitted after all 3 things have resolved. So it's kind of like, that's a great way to force, a convergence point in the flow, right? It's sort of like a countdown latch. I'm saying countdown latch, await the orders, await the profile, and await the customer. And but I don't have to write that weird threaded code. I just get the benefit of that, right? Weird, yeah. So that could be the there's a. I'm not sure if you can see the VMware Tanzu moderator in the chat. Probably can. Weird flux, but that's okay. See, that would be the name of my reactive autobiography. That'd be cool. Okay, so once I've got the tuple, I can then build a customer orders aggregate or wrapper or whatever, and that thing just looks like this. It's just a thing that contains the customer, the orders for the customer, and the profile for the customer, right? And I'm building that, and the result is a stream of customer orders, right? And then remember, when you build a pipeline, when you build a flux in reactive APIs, you haven't made network calls yet. There's no network connectivity that happens until something subscribes. So you have to subscribe. All you're defining is the pipeline. The way that these things get strung together is part 1, but whether they result in network traffic, you don't know about that. You don't know if there's going to be any issues, or if there's any network connectivity issues or anything until you subscribe. And that subscription might very well happen like a year later, right? You could actually start the JVM now, define these 3 things, and then do subscribe like 365 days after you've started the JVM. And who knows, maybe those services don't even exist anymore, right? The point is there's a decoupling between when you define the pipeline and when you actually get the data, the assembly time versus execution time. And that's to our benefit because it gives us the opportunity to rewire how these things get arranged, how they get wired together, how they get congealed into the object graph that we want. And we will see that when we look at hedging, right, which is another section of this chapter. Okay, so in order to see that it's working, I'm exercising this stream. I'm saying, okay, great, customer orders flux. Now subscribe to it 5 times, right? So I'm creating a loop, the old-fashioned loop. And for each customer order flux, I'm creating a start. I'm measuring the start time, and when the stream is subscribed to, that's basically when it's started, when we're actually starting the work of making network calls. And then I also take the start time and I record that, and I calculate the delta between the current time at the end of the stream. So the beginning of the stream and the end of the stream, I'm tapping into those lifecycle hooks to measure basically how long it took, and then I'm subscribing, right? So I'm saying, okay, for each customer order, let's print out the customer, the profile, and each of the orders, and so on. And that works, right? So that's actually, yes, we can. Yep. So that's actually a very convenient way to build services. And again, consider that pod example that I showed you earlier, right? Earlier, if I wanted to render a view based on these custom orders, there would have been all sorts of stuff, right? Task executors and cyclic barriers and countdown latches and all sorts of stuff to make it easier to describe the concurrency that's intrinsic in what I'm trying to do here. But I don't have to worry about that here. I'm saying get the orders. That'll happen on a separate thread, and I'll get a result back when I get the result back. Ditto for the profile, ditto for the customers. And, I just use map. By the time I get to execute this line of code, it's already made 3 different network calls concurrently, and I've gotten all the data, and I can write code against those objects in memory, right? But no sooner. That's just very, very powerful. That pod system would have gone the way, would have been, irrelevant in this case, which is good. Great problem to have. So I guess we can run it. Let's see what happens. But I need to remember. So we need to run a lot of different services here. Okay, so do I have anything running? Service registry, goodbye to you. That one, can you see that? I inadvertently left that running, so that service registry had already been running for 16 hours. Poor service registry. Okay, so here we go. I mean, service registries can definitely run for as long as you want them to. I just feel bad when I run them just for demonstrations and I forget to turn them off. Reminds me of that, Mr. Meeseeks from Rick and Morty. In existence is pain, right? Like they don't want to exist too long. They're just there for the demo. Okay, let's see. There's my service registry, and we need the order service. So cd order service -f pom.xml spring-boot : run. Let me just take all this. And we got the customer service, ditto for this one. And we've got, so what do we got? We have service registry. Which one is this one? I've already lost track of which ones I started up. Customer service, order service, so we need profile. Alrighty. There we go. So now we have 3 services, and now we can actually run this thing, I hope. Do I have any profiles? So because I've got, like, in my code base, I've got a whole bunch of different services, and I've got the thing that demonstrates how to use them, and like I've got a slow service and a service that produces errors, right? So if you're wondering, no, this isn't just a PHP code base, okay? This is actually a Java service that I've intentionally added errors to, and this is a slow service, right? This is just going to slow down the results, and I'm using that from my client, which is just the hodgepodge of examples that I'm going to show in this book that demonstrate different principles. And so the scatter gather code base is in there, but there's a bunch of other stuff as well. So let's see, we went with the scatter gather application. Let's just run that, see what we get. Because, so great question, why does start.set, so instead of pets versus cattle, it's Ricks versus Meeseeks? Yes. Yeah. So the question is, why does it not complain about the variable not being effectively final? And that's because I'm not reinitializing it, right? Where's that code? Where did I put it? Down here, maybe. Yeah. So this is initialized here. I'm not initializing it to a new variable. I'm not saying start equals something. I'm saying start.set. You can call methods on already initialized effectively final variables like start. Does that answer your question, my friend? Okay. So there you go. There's our customer name and customer profile, and I shouldn't show the password. That's very rude. And then the orders, which you'll recall are arbitrarily generated. So how cool is that, huh? We've got the same records. Oh, there you go. That's interesting. I've got a bit of a bug, don't I? Oh, I ran it 5 times. That's right. Like, it's like, why is the same data showing up multiple times? Okay, so let's just try 1 time, and we'll see the results. Remember, subscription is asynchronous. This doesn't block, so there's no guarantee that the first time this runs that it's going to wait for all 5 or all 3 of the records to come back before it logs out the others. So, okay, there you go. We've got 1 record for Artem, number 7, 1 for Zen, 5, 1 for Mia, number 2, and 1 for 1 Jane. Okay, so there you go. And then, yeah, that's just me. That's the do on next for the individual streams, but that's not the actual customer orders aggregate printout there. So that worked, right? You can see it's working. And I just run it 5 times so we can kind of see what happens. But that's when you do it 5 times, you run the risk of having all the results, intermixed, interleaved together. Okay, so that works, right? The reactive stuff makes this much, much easier to sort of reason about and get the results with, and so on. Actually, okay, so that's one kind of thing. The other thing I showed was hedging. I think is a super useful pattern. Hedging is pretty simple. I'm gonna just use what I want to do is I want to make a call to a downstream endpoint, and I want to get the result back. I want to get the first result that can give me a result. I want to keep that one and discard the other one. So that way, if I have an endpoint that's important that I return in a reasonable amount of time, I can use this pattern called hedging to guarantee that I do so, right? A lot of times people use timeouts. I think timeouts are fine, but they don't actually solve the problem, which is to get us a result most of the time. Now, if you have an endpoint that's idempotent, that is to say you can make as many calls to it as you want without any undue observable side effects, then this pattern is ideal. So what I'm doing is I'm saying, let's make a call to this slow service, greetings, and get the data and then turn it into a greetings response object. And here I'm registering a filter function with my web client, and this is called my hedging exchange filter function. I just wrote it for this book, and what it does is it uses that really spiffy, brand new Spring Cloud Load Balancer API. Oh, the Zoom meeting has ended. That's okay, friends. I'm okay with that. Close Zoom. If I close Zoom, is this going to end everything? No, we're fine. We're fine. We're fine, folks. We're fine. It's okay. Okay, so I was on a Zoom meeting before we jumped on the Twitch stream, and apparently that one was just idle in the background there. Okay, so this hedging filter function is using that really spiffy reactive Spring Cloud Load Balancer API built by the Spring Cloud team and Olga in particular, I think. Is it Olga? Yeah, she's awesome. Okay, super awesome. So this is pretty straightforward code. This code you shouldn't write yourself because I'm not even sure if I got it right. And pretty sure though. Like, let's just take a look at it. Basically, it's a filter. It runs on the client. It runs on the reactive web client. As the requests come in, as I make requests outbound, rather, I want to pick apart the URL, get the host name, treat the host name as a service instance, use the service instance factory to get a resolved instance given that host name. So remember I told you that the Spring Cloud service registry, the discovery client abstraction gives me the ability to ask the service registry for an instance. What I'm doing is I'm asking it for a particular instance. I'm asking it for a load balancer for a given API, and then I can use that API load balancer. Actually, that's a good point. If that's not clear to me, why would it be clear to anybody else? Refactor API load balancer. Okay, and I'm going through and I'm saying, okay, I want to get max nodes, right? Max is like how many discrete instances can I get? I'm keeping a list of them. Although that makes me kind of wonder if I should have. Oh no, that's right. Yeah, okay. I'm going ahead and I'm getting as many as I can that are under that threshold. And for each one, I'm making a call to the load balancer. And for each response that comes back, I am calculating a key here, right? And the key I'm using because I don't want to make, I don't, like, in theory, this load balancer could give me the same instance over and over and over again, right? It probably won't because it's got an algorithm, like it's going to do round robin or LRU least recently used or something. I don't even know, but in theory, this could just choose the one instance over and over and over again, right? And so at some point, I want to have some smarts in there that says, oh, hey, you're calling the same host and port 3 different times. That's not going to solve the problem. In fact, if there is actually an underlying problem at that host and port, then pelting it with 3 different requests at the same exact time when you could be calling 3 different services is just going to make matters worse, right? It's not great at all. So that's what this bit was meant to do. I'm not even sure if I ever followed up with that, but there's something there. I need to figure out a way to, keep a map perhaps, and then, or a set, use a set to calculate the, like, while responses.size is less than max nodes. Actually, I could do that here maybe, right? I could actually say if this key, so does this, I could, like, suppose I did this. Like, what if I did mono.empty? What if this key, if it already existed in some data structure that's designed to dedupe the collection, to dedupe its elements, what if that already existed in the set, right, or in the map for the keys? If it already existed, could I just return mono.empty, like in this case, right? What would that do? What would the effect of that be? In this case, I wouldn't want to calculate based on responses. I'd want to calculate based on, like, the question is, what happens to the mono.empty downstream? I guess I could say filter on the next line, right? I could say filter so that it has to be a not empty thing, that's interesting. So we could try that. Let me write that down. That'll be worth exploring later. Use the check if the key, first of all, to do, check if the key exists in a concurrent skip list set, and if it does, return mono.empty, change the condition to check not responses dot size, but check unique keys dot size, right? Or unique hosts dot size. Okay. To do, change the map to return mono dot empty if the key already exists in the set, and otherwise to do, change the next line to filter the non-empty elements. Okay, so that seems more reasonable actually, but in that case, because there's a possibility I might get the same one. I don't know, probably not a real issue, but there's a possibility. Then I take the URI and I invoke it, and when I invoke it, all I'm doing is I'm taking the URI, the client request that represents the incoming request, and the function, and I'm just proxying it. I'm creating a new request that mirrors exactly the incoming request. The only thing that's different is I'm using a new URI. I'm actually using an actual resolved host and port as opposed to a service name for the host. Okay. Seems like tuple and concat map is probably, yeah, that would be. You could do reactive discovery client get instances, which returns a flux. Oh, there you go. Yeah, okay. That's even better. Use reactive discovery client dot get instances. Take n, which returns a flux service instance. Okay, see, that's even better. That might be the winner right there. Nice. Okay, we'll investigate that soon. And the result is basically we're making a call, but what we're doing is we're invoking the same thing, right? I'm building this request. I'm building the result of this call is a timeout, and a call to the downstream thing, and I'm adding that to responses here, right? I'm adding it to the responses, and that gives me a list of mono of client response, and I want to turn that list of mono into just a list of client responses. So I do this very unfortunate thing here where I'm saying take a list, turn it into a publisher, and then flat map itself just to unpack the nested type, which is also, it's gotta be, I could swear I used to know a way to avoid that, but whatever, it works. The result is a publisher of client response. Seems like this would be, like if they just had that and it just equaled the identity version, that'd be interesting. Okay, and so I'm saying, okay, get all the results and then find the first one, right? The first one that responds, I want to keep that, take it and then return. Okay, so that seems to work. And the service itself, slow service, the slow service is just a simple endpoint. It returns a greetings, but I do so by delaying the subscription by a delay time, right? A value there. So the application gets configured with a DTIM of 0, but let me say I log the port, and is there a property? I think there's a property. Oh wait, there you go. I'm sorry, that's not actually 0. It's rsb.slow service delay. So when I run this application, when you run it 3 different times, you can say dash dash, rsb.slow service delay equals 5, whatever, or 10, or whatever. And so if this hedging algorithm is working correctly, then no matter which instance you specify should be the slowest, that one will never be in the results that you get, right? If you launch the slow service 3 different times, they all register with the service registry, and then one of them will be fast, the other 2 should be slow. You should always see the fastest one giving you the response. And I note the port here just so that I can include that in the output of the message that gets sent back from the greetings client, so that we can know which one is actually working. Flatten. There you go. That's much better. Is there a flatten? Oh, you got me. You got me. It would have been nice if there was a flatten operator. Yeah. Okay, so that's the basic pattern. I guess we can try it out. So let's see here. What do I need to do to make that work? I need to start the slow service. Here's fast, slow. Let's run this one. Okay, so that's up. If I go to here, slow service, 1 instance, right? That's the fast one. We can run another instance of that service here. Slow. This is all I've done is I've configured some profiles here. The RSB slow service delay equals 10 for the slow one, right? For the fast slow service, it's 0. Okay, so I'm just launching them with environment variables to configure them. And slow again. So in theory, did I log out the DTIM? Configured. There's this one, that's 10 for this one. Slow. 10 for that one. And then this one, it's 0. And so it's on port 54351. So when I run the hedging application now, we should only ever see the response from 54351. That's the theory, right? If this is working correctly. And again, who knows? It's all to be, there you go. Okay, 54351, right? Gives me the right one. So the key is blah, blah, blah. It evaluates all 3. The only one that it keeps is this one, 54351, because that's the fast one, right? So go there. There you go. And you can try the other ones. Service registry. Where'd you go, service registry? There you go. Actuator of greetings. That one is 54351. That's a good one. Here's greetings. Slow, right? It's going to take time. You can still see it's swirling, and there you go. We finally got the result there, and so on. Okay, so that actually works. I like these suggestions. I like the reactive discovery client, so that'll make it nicer. Yeah, if I turn off Slack, it'll be faster. Am I running Slack? No, don't scare me. I don't have enough power for that. This is a 64 gig MacBook Pro with all the extra toppings and all that stuff, but I still don't have enough power for Slack. So it's very important that I can do this or that, but not both. Okay, so I like the this hedging pattern. Very, very convenient. Obviously, don't do that, as I always admonish people. Don't do that on the unknown. Don't do that on the charge the customer credit card endpoint, right? It has to be on the endpoint that you can make idempotent network calls to. Okay, so that's working. That's one chapter, one section of the chapter we're going to talk about. I've also got a whole section on resilience for J. I think resilience for J is pretty neat. So close this down here. And we've got, oh, and by the way, discovery. Do I have anything in there yet? Not really, no, so we'll come back to that. I've got a whole section on resilience for J, where I basically demonstrate the 4 different things that you can do to make your network calls more resilient. Now, so one thing you can do is that they have support for circuit breakers with resilient for J. So circuit breakers are, it just makes it so that if you get enough successive errors from a network call, you can fail fast. You can actually just have the client fail, and then you can choose to call something else rather than try and make the call, wait for it to fail again, and then delay the client. If enough successive calls beforehand have failed, why bother keep trying, right? So you can create a circuit breaker. The circuit breaker keeps a Boolean, basically. It says open or closed. If it's open, like an actual circuit, then of course no data is going to get through, no electricity gets through. You need to have a circuit it needs to be closed, right? So if there's enough errors, the circuit opens, nothing gets through. That's fine. You can see that it's closed or open, and if it's open, you can decide to do something else. Fairly easy to understand. In this case, it's open if you get a call not permitted exception. So I'm making a network request down here. I just have a plain old call down here, right? Oh, that's interesting. This is doubly circuitous. There you go. Okay, so I'm making a network call. All I'm doing is I'm making a network call using the reactive web template, just like before, calling the error service, giving it a UUID, getting the greetings back. And I'm adding a bunch of stuff here to monitor it. So to log out if there's an exception, to note when it subscribes, and to note when I get each result back, and so on, right? Because it's a mono, so by the time I get the first result back, that's the end of the stream. It's the same thing as do on terminate. I just care about that. So so the circuit breaker demonstrates that particular feature. I think that's kind of interesting. You can configure how many calls you should be allowed to make, how long you should, what exception should fail, etc. That's one use case. The other one is the retry client. You can actually configure a operator here on the web client, right? You can configure an operator just as I did before, transform deferred retry operator of, and you can configure that you want to retry, so many calls, you want to have an exponential back off, and you want to do a certain multiplier, and you want to try 3 times, and so on. And if you do that, it'll retry the call. So if you try it once and it fails, it'll retry it again. I've configured this endpoint called retry in the error endpoint, in the error service here. Okay. This retry endpoint is designed to keep track. So assuming the same UUID for the client, token or session or whatever, I'm just keeping a map, just for demo. Assuming the same UID, I keep count of how many requests we've seen. If it's more than 2, then we actually succeed. Otherwise, you get an error. So the retry will fail the first two times, and because we're keeping track of that, we're acknowledging how many requests we've seen from that particular client. So the message you see when you run the retry client should reflect the fact that this is the 3rd attempt, which, by the way, is also the last attempt you would have gotten before the retry just gave up and threw an exception by itself. So that's pretty easy to understand, I think. The rate limiter client, right? We've got a rate limiter client here as well. The rate limiter measures how many requests you can make in a given period, right? So within a certain interval. So what I'm doing here is I'm saying I want to make a call to the greeting service, again, to the OK healthy endpoint that we've been using a lot recently. By the way, go back to that. I just realized this is everywhere else. I'm doing transform deferred down here in the build request endpoint. Okay. Rate limiter, yeah. So here I'm making a call to the downstream service. I'm using the rate limiter, and the rate limiter is going to make sure that I make no more than 10 requests in a given period. The period in this case is configured to be 1 second. So every 10 seconds, every 1 second, I can make 10 requests, and I can possibly time out for 25 milliseconds. Okay, so that's the basics of it. And what I'm doing is I'm just using I'm building the request. I'm building 20 requests, and I'm expecting to see that 10 of them have errors because they were rejected because of the circuit of the rate limiter, right, errors that increment and set, and I should see 10 of them get through, right, because the rate limiter is only allowing 10 requests per second. It doesn't take a whole second to launch 20 requests, so I launch all of them in the first second, and the only 10 of them come back, right, as we expect. The other ones fail because of the rate limiter. So that protects the downstream service from being overwhelmed. That's a very convenient thing. Now, this is one approach to rate limiting. Later on, we actually look at Spring Cloud Gateway in this chapter, and there's yet another approach to rate limiting. So it's really convenient that. Okay, so that's this one. And then there's the bulkhead. Now, this one's actually, I don't know how to test this one. I don't know how to do a provably. This one's actually really hard. Bulkheads, by their very nature, are sort of like you shouldn't need them if everything's going all right with reactive. Any suggestions for non-blocking rate limiter on the server side? Spring Cloud Gateway, I think, or maybe you can use. Does the Alibaba Sentinel rate limiter work in reactive applications? I think it does. That we'll talk about that in a second, right? But this bulkhead, think about what a bulkhead does. A bulkhead, it says, I don't want to waste more than 3 threads on this call, right? Or whatever. There should never be more than 3 requests or 3 threads for a given thing. And so the goal of the bulkhead is to make sure you don't create unlimited threads trying to solve a problem when you don't have unlimited threads, right? It's to constrain that. But what does that mean in the world of reactive programming, right? Reactive programming, you've got very few threads, right? And more to the point, the runtime, the whole point of reactive, the whole conceit of reactive programming is that the runtime is going to make sure you don't waste too many threads. So unless you're doing something very wrong, which I have to do in order to demonstrate this, right? I have to do something very wrong. I'm not even sure if I see the value of the bulkhead in the reactive world. I mean, I guess that it's there, right? There must be a reason. I just can't figure it out. So here's what I've done to make it fail to be not exactly like I would expect it to be, right? I build the request given a scheduler, right? So you can see I'm creating an immediate scheduler. The immediate scheduler is going to run the call, the network call, on the current thread, on the client thread. It's going to force it to be on the current thread. So I've lost right out of the gate. I may as well not be using reactive at this point. So, and then I say, okay, I calculate how many processors I've got on my computer, because by default, the reactive thread pool that you get out of the box is equal to the the number of processors you've got in the computer. In my case, I happen to have, I think 16, Java sees 16 different processors, right? I think I actually have 8, but there's 2 cores, or maybe it's 4, I don't know. Either way, I've got 16 processors, and so I want to divide that by 2. I want to say, okay, even though I've got 16 processors, I am going to only allow my network call to use half of those 8, right? And so I'm going to launch 16 network calls, right? Using this request, I'm going to build 16 different requests, and I'm going to subscribe. So in theory, all of them are being launched. And then I'm going to use the bulkhead, and the bulkhead's I'm going to tell it to subscribe on the current scheduler, to publish on the current scheduler, and so on. So I'm using the immediate scheduler for everything. And then I'm going to go ahead and try and get the results, and basically it'll reject half of those requests. But again, normally you're not going to do this. You're not going to be forcing everything to be on the current thread. It's the antithesis of reactive API. So I feel like this is a bit forced. It is a bit forced. I'm wondering if you even need a bulkhead in the reactive world. I guess you do if you haven't done your due diligence and gone through your code with the reactor block hound, for example. Then you might want to make sure, if you're doing something that blocks anywhere in the pipeline with a publish on or whatever, then you might want to use this, I guess. But this makes a lot of sense in a non-reactive world. It's just the reactive stuff that kind of weirds me out. But anyway, that's resilience for J. And then gateway. So I've got a bunch of things here. And the way I wanted to introduce gateway was to introduce a simple proxy route, like just an absolute basic, start here kind of thing, a path, an incoming predicate. So if you haven't used Spring Cloud Gateway, what you need to know is that you can create one or more routes. Each route has a predicate that matches the incoming request. There are filters that act on the request, and then there's a destination to which the request should be forwarded. So I'm saying take the incoming request coming to whatever port my gateway application is running, and then take that request and strip it of its path, set a new path, which is guides, and then forward that to the new URI, which is http spring.io / and then guides, right? It gets added onto that. So that's a very, very simple example. And the result will be that you get the HTML assets from spring.io / guides if you do curl localhost, whatever the port is for this. And then slightly more progressively interesting, you've got the load balancing version, right? Where here I'm load balancing, I'm actually making a call to the error service, to the OK endpoint, which just, that one's fine. And that works, right? It's very simple. Another example, filters, right? I demonstrate some of the interesting filters that you can get out of the box here. So setting the path, actually, there you go. So I'm setting the path, I'm doing a retry if I need to, I'm adding a request ID, a request parameter, adding a header, and I'm doing a custom filter. It just doesn't do anything useful. It just logs the start and the stop, that kind of stuff. No, it just logs the fact of having started and stopped the request. I could time it, I suppose, that's fine. And then for all of that, we send the request downstream, and that is very much as it was before. Another one is the events. So here I'm looking at all the different things that could cause when you're using the load balancer, when you're using this, then it becomes very important that you understand what might change my definition, my working understanding of the topology, or the topology of the services out there, right? So you can listen for events. And so here, this is the last thing I was working on. Like last night I was working on this. So it might be, this is a little raw. This listens for all application context events. And I check the class name and I log it out and add it to this set of events, and then that way I know the unique events. Okay, and actually I'm not even sure if I benefit from that, do I? Beyond just, oh, I need it to dedupe, but again I could have done that. Oh yeah, I do need that. Okay, so I'm just checking that to make sure I haven't seen the event, because some events get emitted multiple times. I just want to get a unique, distinct set of the events that get emitted. And then there's the refresh routes event. Now this event is a meta event, right? So this event gets published by this route refresh listener, which in turn listens for context refreshed events, refresh scope refreshed events, instance registered events. This is for the service registry, right? The parent heartbeat event, what is that for? Is that for that's for the service registries as well, and then for the heartbeat event. So anytime something changes in the world of our services, right? If there's a new service that's been added to the service registry, or if a service has been taken offline, then we'll see that reflected in these last two events. And also, if somebody has asked for our application context to be refreshed, or for the refresh scope, if the actuator /refresh endpoint has been triggered, or anything like that, then we also do a refresh. So any of these events trigger a reset, well, or possibly could trigger a reset. And all that does is in turn result in a refresh routes event. So the refresh routes event in turn gets published for other things in the system to listen to, of which the caching route locator is one very interesting one. This is by our buddy Spencer, who's in the chat today, or at least he was. He might have run away after seeing my terrible code. So here's the caching route locator. Now this thing, it just caches the routes. It caches the working knowledge of the routes in the system using this very cool, and I didn't know about this thing. I learned about this last night. This is super cool. The cache flux, very convenient way to say, hey, give me a reactive stream of things, but make sure I don't unnecessarily resolve anything. If it doesn't exist, then use this fetch method here. And that's just calling the delegate, the original publisher, to get the routes and to sort them and so on. It's a list. Or, sorry, no, it's not a list. Oh, that's cool. You can do a sort on a publisher. Yeah, lots of good stuff in this class. So what else do we have here? So refresh. This one, I'm not sure if we need to spend too much time in this class, because it's not really, this is just my kind of experimentation trying to see where things ended up. But when you run this program, you can see the events, and you can also see that, for example, I can get access to the routes that the caching route locator has. And if I enumerate all those routes here, I'll see this one route and the metadata associated with it logged out there, right? Hi, Spencer. So there's that. What else? We've got security. So the next thing I do is I introduce the rate limiter. And rate limiter is a special kind of filter. It's got its own, it's worth its own few paragraphs is all I'm trying to say. That's just code for, I'm going to spend a few paragraphs on it, whereas I didn't spend a few paragraphs on each individual other filter. And this filter requires a bit of setup. That's why I wanted to separate it out. So the first thing you need is a Redis-based rate limiter that's going to configure how many requests you can have per second. And the Redis rate limiter, it's talking to Redis. Redis is a distributed data structure server. It's a distributed map, if you will. It's got keys and values. The values can be all sorts of different things, including atomic numbers and so on. But the keys are, it's a key. It's a string, right? So given a key, we can resolve an atomic integer, which gets used in counting how many requests are allowed for a given client, right? And we do that by resolving a key. So one way to get the key is just to provide a new key resolver like this. If you wanted to do, the whole world one key, then you can do that. But if you want to have each user having their own key, then you can use the principal key name resolver. That's actually the default, right? I can actually just take that off and it's the same thing, but I'm making it explicit so that people can see what's happening here. And what this does is it looks at the current principal, gets the principal, checks the principal's name, and does a switch if empty and returns empty if it's not there, right? So here's this. I've looked at this class only 5,000 or 6,000 times in my life. So that's pretty straightforward. This is a little bit different than the thing that we looked at before. Before, with the rate limiter that comes with resilience for J, we're acting as a client to a downstream service, and so we're using the rate limiter there to prevent the client from overloading the downstream thing. Here, we're also doing that, but we're also acting as an API, right? So somebody's going to make a request to the gateway code, and we're going to hit the gateway, and the gateway is going to look at the request, and it's going to apply the rate limiter, and then if the rate limiter allows it, it'll forward the request downstream, right? So it's not just purely a client perspective. I mean, I suppose it is effectively, but somebody else will be the client of this gateway, right? And of course, in order to use a principal name key resolver, you need a principal, right? And that's Spring Security's purview. So that's why I've got Spring Security here, just a default. What is the deal with that? Whatever. Okay, so that's the preview of my basic configuration here. I'm saying enable HTTP basic, disable CSRF, lock down everything, open up everything except for the RL endpoint, which of course is the rate limited endpoint, just a single user and password. It's fine, and so on. So that's my gateway rate limited endpoint. Pretty trivial. Oh yeah, that's a good point. Spencer makes I used Redis to keep track of if I have 10 instances of the gateway in the service in the load balancer in my my AWS ELB or Cloud Foundry's Elastic Load Balancer or whatever, then I want to make sure, or Kubernetes, I want to make sure that the count I'm keeping for each of the downstream services is in aggregate across all the different gateway instances in the load balancer, not unique. So that if I configure a load balancer capacity of 5, but I'm only keeping track of that count in my Java code here on this one instance, then as soon as I add other instances, I've now done multiplications of 5, right? So 2 instances is 10, 3 instances is 15, etc. So keeping track of that in Redis means that all clients, all gateway nodes, see the same count. They see the same number consistently, right? And so there's contention. Okay, so that's this. And what else was I going to show? I showed all that. The other thing I was going to show. So okay. I guess the things I wasn't sure what else I wanted to show here. Perhaps the fact that I can do refreshable routes, that seems interesting. We could code that for the next bit. The other thing I was going to show is like in theory you could. So this interface right here is it says this interface here is a route locator. It's the simplest, most deceptive interface in the whole world. Look at this thing. All you have to do is give it a stream of routes, and suddenly you've got a gateway. And so, in theory, and again, I could be wrong, but in theory, I could source these routes from anything, right? In fact, they've even made it easy to do. The constructor supports just plugging in the bits that are required to make this work. So one way to source those routes is to use YAML files, right? To use configuration. Oh yeah, did I not show that already? The automatic routes from the Discovery client? I don't think I did. Okay, so configuration class Discovery Client Routes configuration. And I think I even had that up here somewhere. This thing here. So that's the property, but I don't want to do that for everything. So let's see here. Oh, I did have this. I've got the endpoint for actuator. I was going to show that as well. That as well, but I don't want that. What happens if that thing is active at the same time as, like, can I still use other non-Discovery Client bound routes? That should still work, right? Either way, all this does is it adds a bean if memory serves, so I can do the same thing myself. Okay. This one. So find usages. Yeah. Oh, it's passing in the properties directly. Whoa. Okay. Well, either way, we can use that property or and turn new this bit right here. I need a reactive discovery client. And I need a discovery locator properties. Is that property not going to be active if I don't have any properties configured for it? Like, is it a conditional? Let's find that out as well. So, I mean, oh, so I've got a chicken and egg problem. So I can't, so okay, Spring Boot won't really manufacture this bean, will it? Oh, yes, it will. Yeah, okay. Even if I don't prescribe, even if I don't use this property anywhere, why would it do that? So let's see. So if I get rid of that, right, then why would Spring Boot have any reason to configure this? Well, it has defaults though, you're right. Okay, so I can just inject the existing one. Good. That should work, right? I can do that. So that way this can be under profile and discovery routes, whatever. So, all right. That could be cool. So that's route definition locator and route definitions. I'm not actually, it looks like that's even easier to factory, basically. Routes, what does the route contain? Oh, it's based on a string. Okay, so the whole thing is based on is this for the YAML definitions? Basically, is this a pass through? You just I do the YAML and I can dump the strings that get passed into this, and that gives me the actual route infrastructure. Yeah, okay, that's what I thought. This is a thing to take stringy bits. I can tell now. Okay, I can see that because it's text, right? The constructor's text. It's like, oh, okay. So that's interesting. So for me, I'm still more interested in just routes themselves. It looks like I could actually, and again, maybe Spencer can steer me clear of this, but there's a YAML based configuration, right? I'm going to show that in the book. I'll show the YAML configuration because there's an interesting opportunity there. You can actually store the configuration in the Spring Cloud config server, and then you can use refreshable endpoint, refreshable configuration using the refresh scope to, in theory, refresh the routes without ever recompiling the Java code. So you can actually use your API gateway as infrastructure as opposed to just a Java API. So route definitions plus predicate factories plus filter factories equals routes. Yes, okay. But routes configuration, like route locator, my custom locator. Like, how hard is it to create a single route? Compile route definition locator. It's this thing here. Yeah, not so easy to remember or keep all that in mind. Yeah, I mean, this is why I'm writing a chapter on it, because all this stuff is it's useful. You want to know about the stuff when you're thinking about how you wire together otherwise uh, independent services, right? How are they supposed to coordinate with each other? Gateways are a big part of that. Reliability patterns are a big part of that. Scatter gather composition is a big part of that. Okay, so this is where my head is, right? I look at all this beautiful code, but like I'm so tempted. How do I build a route? Just a single route. Route. You have to spell it in order to do it. That's the first part. New route. Nope. Okay. Yes. Bon appetit, bud. So there's some interesting opportunities here, right? Routes, there we go. So we're converting to a route. So we're taking the route definition locator, getting the route definitions, and then converting them to routes. This is where the magic is happening. What I want is to create my own route locator. And that's interesting, right? Because you could actually have a route locator that loads routes from a database or from anything, right? You could, like, whatever. You could have routes that are created based on the health checks of some other services. I suppose that's kind of part and parcel of the routes based on service registry routes, but lots of opportunities there, right? So how do we do that? Convert to route. So given a route definition, this bit, given a route definition, this bit is the thing that actually creates the route. So route.async, that route definition, async predicate, replace filters, and build. Oh, okay, well, that's actually a little bit tedious, but async predicates. So the predicate, so this route business, right? What we're doing is we're saying load the predicates. That's the part that matches the incoming request. Create the filters, right? Load the filters, and then build it. So let's try it. Let me just try it out here. Route dot builder. Oh, async dot async predicate. New async predicate. Okay, so given an incoming request, we determine whether to match it or not. So I'm going to say mono.just true, okay. And then I want to have some filters. Oh, look at that. I can configure filters, new gateway filter. And then what's the bit where I actually send it onward somewhere? URI. So I think, my friends, that is actually the same as what I've just done, right? That's actually the same as the higher level Java API, which is what you're going to use 99% of the time, of course, because it makes sense. This is still a lot of code. But look at that. Now we've got a custom route, right? That's the route. So now I can return that. I can just say build, okay. Single route. There you go. In theory, that's the same thing as like in theory, I can build my own gateway programmatically using just these APIs, which is that's pretty cool, right? Like imagine what you could do if you plugged in Spring Cloud Gateway and had it talk to other things. Keep in mind, I'm having trouble thinking of what I would like to plug into because it already does all the things I can imagine wanting to do. But in theory, these routes could live anywhere, right? You could read from any data source and then use that to build up these route definitions, right? That's interesting. The possibilities are pretty cool. So that's I'll play with that some more. I suppose that's worth looking into. Okay, good stuff. And actually, the interesting bit, we can actually, again, there's no reason we can't use new. Well, what other filters are there? There's a bunch of them. Spencer wrote a billion of them. So look at that. Set path. Gateway filter factory. So dot apply. Mm-hmm. Apply. It's going to require some config, huh? What's this config business? Set the template. Is it just that? There it is. There's our set path gateway filter. Okay, so take that. And in theory, I can do that. Cool. So let's try this out. Okay, so we're going to say, okay, when the request comes in, we're going to match it. We're going to say, yes, we accept that request. This is predicates, right? And then we've got the filter. We've got just one. We're just changing the outgoing path so that it says guides. I think that's going to work. I don't know. We'll find out. Set template. What does this actually give me? Set template. Append URI variables. Yeah, okay, we're using the URI variables. We're using the template. Okay, that makes sense. So what does the template key give me? Okay, well, we'll figure it out. I'm not sure what it is. Let's just run it, I suppose. So, okay, we're going to have custom route locator. Comment this out for now. This is, in theory, my custom, yeah, okay. My custom gateway route locator. So there's this bit. Let's try it out. Run gateway application. ID cannot be null. Fair enough. This will be called Spring IO guides. I hear a helicopter. Hey, that worked. How cool is that? So if I go to curl HTTP localhost, on what port am I running? Okay. I got a 301. Oh, that's so cool. So what's the URL that I should follow? 301 moves per, oh, it's HTTP. Oh, that's interesting. No, what I got was so the set path filter isn't quite working. It's interesting that it worked. It's just not, this part isn't working. So the template is not what I thought it would be. I wonder if this helps. Not quite. Got an error. Okay, so what's the issue here, friends? That's interesting. So it's not quite working. Let's find out what this thing looks like when it's doing the work that it does. So find usages, set path, gateway. URI template. So let's just debug this. I'm kind of keen on seeing what is actually happening behind the scenes when I involve this. Config.template equals guides. Okay, makes sense. So then I go into this bit here. And now I'm taking the incoming request. Let's look at the variables there. Request.path is equal to / localhost 8080. It's localhost 55. I'm not sure if you can see that, 55744. So the path is / get the template variables. Is there anything in that? Don't think there would be. Yeah, it's empty. Good. Go down one more level. URI is guides. That makes sense, right? It's guides. New path is equal to guides. I'm adding the attributes to the exchange. What is, so this gets used, this attribute gets used later on. So what is the full URI? Okay, guides. Gateway request URL attribute. Where does that get used? By whom? Oh, okay, so it's mutating the path there. So what does request give us now? If I ask request for the URI, oh, that's interesting. It gave us localhost 55744, which isn't quite what I was expecting. So it's changed the incoming request. I guess that makes sense if it's going to preserve that for the outgoing one. But how do I know if it's actually worked? I don't have access to it at that level, I guess. So if I go down, filters. Who uses the route locator? That's the question. Find usages. Composite route locator. Get routes. No, we don't want that one. We want the caching route locator. Okay. Sure, but who uses this thing? That's the question. Who finds the route locator beans and then turns them into HTTP endpoints that I can invoke oh yes, this probably, now we're cooking. So something registers this route predicate handler mapping bit. That's a HTTP endpoint, right? That's the abstract handler mapping. Cool. Gateway predicate route attribute. So this is the lower level Spring WebFlex handler. This abstract handler mapping is from Spring WebFlex. It's just a mapping between higher level code, in this case the gateway code, and the lower level web runtime in Spring WebFlex, right? So what we're doing is we're creating a thing that takes those routes and turns them into actual requests or into actual endpoints that you can invoke for you. And it looks like this is the actual bit that's doing that. So given a request, given a server web exchange request, we put the handler information in the current incoming requests attributes. We look up the route for the exchange. How do we do that? Oh, hello. So we say route locator.get routes. Okay, now we're cooking. This is where the rubber meets the road, right? This is the thing where we're actually, that it's going to find our bean, the route locator that we've created, the custom one, and apply it. So gateway, get predicate. Validate route, lookup route. So I'll find usages for that thing. Okay, so it's going to find the route for that, and given a route, we then check the route attributes, get the attributes, return the web handler, route predicate handler mapping. Oh, could be useful later. Route predicate handler mapping. That's us. Okay, so oh wow, there's so many things you have to worry about when you're building a gateway, and you can really see all that. It's amazing that we can have that, just that one little route locator interface, and it plugs into this really comprehensive machinery here, you know. Look, it's got support for cores, right? You need cores, of course. Wow, okay. So given a route, we validate the route, return it. But who uses this bit? So lookup route, we already did this before. We backtracked somehow. Wow. Okay, there we go, flat map. Okay, so we're back to this. So here we're given a, when we call lookup route, what are we given back? We're given a publisher with a single route in it. So how are we flat mapping? Oh, we're given a function. Okay, that's interesting. So you can do that here. You can say mono dot, sorry. You know what's been interesting for me? I just moved house, and so one of the privileges of that is I finally got a monitor and a keyboard. All this time I've never owned a place big enough to handle a desk, a proper desk, and it didn't really matter because I spent most of the last 10 years in hotels. But now, pandemic, I'm actually at home, and now I have a little bit of space, enough space for a table of about 4 feet wide, which is nice, and a monitor. And so for the last, I don't know, 2 or 3 days, finally things are starting to come together, and I have a monitor and a mouse and a keyboard. But now I'm out of practice with my MacBook Pro's keyboard, so I'm using that to stream, right? Because I don't want to deal with resolution issues on the regular one. But so now I'm typing, and it feels very like I'm walking through mud or something. I'm traipsing through sludge. I just don't know how to use the MacBook Pro keyboard more because I'm so used to the Logitech keyboard I've been using. Okay, so anyway, who cares about the data? I'm just trying to confirm that that works as I expect it does. Flat map. It's very interesting that he's explicitly called out that function. So given a t on the left, you return a mono of t on the right. Okay, that's obvious, but yeah, look, it's very interesting to me that he's got to like spell that out. Okay, so flat map the route, get the route R, get the exchange, get the attributes, remove this attribute. What is this bit here? Gateway predicate route attribute. Okay. Exchange that get attributes dot. Okay, sure. Return this bit. Filtering web handler. What is that? Spring Cloud Gateway. Okay. So we've got a filter here. It's a web handler. This is even lower level, right? Just a thing that looks at an incoming request and produces a response. And actually, it doesn't produce a response as a return value. It's meant to actually do the writing somehow, right? This doesn't specify whether it's a servlet engine or whatever. It could just be anything, I guess. So that's interesting. Gateway filter adapter, doing the adapter, or doing the filtering there. Okay. All I want to prove is that this works. So what's some other thing where we can be sure to see the result if it does work, right? So what other filters could we possibly apply? Let me just backtrack here a little bit here. Let's do a redirect. No. Or oh, that should work. Wait, so okay, set path gateway filter factory. I guess I could try something else here. Like, what if I just start up the service? What I want to prove is that it's going to guides, or that it knows how to go to guides. It doesn't look like it is, though. That's my issue. So, like, why not, right? What do I have to do to get it to do that? Set path dot blah blah blah. Set application event publisher. Why do I need that, right? When does this get used, and does it break things if I don't have it? Okay. Modify response body. This one looks a little bit more interesting. So I mean, I could just do something even simpler, like, so all I need here in theory is a filter, right? Any old filter will do. So let me just put in a custom gateway filter, and I can say exchange dot, chain dot next, or filter exchange, and log dot info. Okay, exchange before and okay. Terminate exchange after, and of course we want the start. So start dot set system dot current time milli, and calculate it over here. So start dot get system dot current time milli minus this. All right, let's run this again. Oh, by the way, for those of you, one thing I didn't show was that to make it easier to debug everything, I've got this little program here. I just wrote a little tiny nonsense program down here. And all this does, it's a little Spring Bean that listens for the web server initialized event. It finds Google Chrome.app, and this event is when the web server is available. It gets the current port, and it opens up localhost / on the current port by shelling out to the command line. So I do open, Google Chrome, passing in that URI, and then I just I make that run, and I get the status code. So all that's doing for me is when the web service starts up, since this gateway code starts up on random ports, right? Because I'm using service registration discovery, and I want to have more than one instance, and I don't want them to ever block the port. It just starts up on random unused ports, and I hate having to go to the console output and sift through it and finding the ports. I just wrote this little program that as soon as the program starts up, as soon as the web server is ready, it opens up Google Chrome to the URL that I got by going to localhost / and the current port. So if I, like here, I'm not even sure if let's see. We should log it out as well so you can see what I'm trying to do. So log out, trying to open URL. Maven Spring Java format. Hello, rude. Okay, apply. Right. Okay, so just clean up the formatting there a little bit. Good. Now, the application ran. It says trying to open up this URL here. Right, that's the URL of the thing I'm opening up in the browser. And that's why this URL keeps popping open. So if I paste that there, it immediately redirects. I hit paste, redirects. And the reason is because if I curl that, it doesn't redirect, right? And the problem is it's showing me a redirect for Spring.io, not Spring.io guides. So actually, that's a good point too. What if I change that down here? HTTPS. Is that why we're getting a redirect? That's probably why we're getting the redirect. It'd be useful to at least confirm that we're able to see the data. I mean, it's obviously doing most of it right. It's just the details here. Okay. Okay, so let's see. So interesting. I got a lot more requests when I changed it to HTTPS, which makes me think there's no redirect. So okay, so that's the home page. So it's clearly going to the home page and not to the guides page. So that filter isn't doing what I would expect it to do, which is interesting. I wonder if it works if I just do that. Well, I mean, it's not going to work now, obviously, because I don't have that filter anymore. But even when I had it, set path gateway filter. Okay, filters. Okay. No, not quite. Not quite. Oh, well, my friends, I'll dig into this. I've learned a lot. Your questions have been helpful. It's been great to have all this feedback, and I have some strings to tug on. This whole streaming thing has been a lot of fun. It's been 2 hours now, but I need to go get some lunch, so I think we're going to call it. But really, just let's do this again sooner rather than later. What a fun thing! It's and I'm up late. I'm a night owl, so I'm much happier to write code late at night. You know, when it's easier. So maybe I'll do this again for European and Asian time zones, make it more accessible for them as well. And I can also do it again on during the day. This is a lot of fun. Thanks to all of you who stuck around. I hope you got something out of it. I did. I wonder, is this fun for people to watch? I don't know of many other programming streams. You know, I do know that I enjoy watching streamers play. You know, Zelda Breath of the Wild, the video game. You know, that's a lot of fun. But what about code? You know, and so I guess we'll find out. I'll just keep doing this. I know that you know who does a lot of streaming. My friend Holden Corral. She's a Spark. You know, the streaming data platform. She's a Spark engineer. She streams all the time on Twitch, and I've always thought, you know, that's pretty cool. I wish I could do that. You know, so here we are. Look at that. Learn something new. It's a brand new experiment. Um, thanks everybody. Hope you have a great day, and we'll see you around. I have a Twitch stream, by the way. I should say that I have a Twitch stream. Java, Josh Long. Find me there because I'm not sure if I can use the Tanzu one all the time, you know. But if I can, I'll just use that. Cheers, everybody. So now, how do we even stop this thing? I guess we just go to end, stop streaming. And